Okay, we're going to have a look at some of the other components we've got to make for this lamp now. Here's a good example of a lamp. I say it's good. It's not perfect because the lamp is set up as a balance lamp. So this counterweight here, even though this edge of the balance bar is shorter, this counterweight is supposed to keep that in a stable equilibrium. So that should always stay balanced. So it's slightly out, but it's not a biggie, right? So what we're going to look at making here is this part here, which is called part one, the support arms for the lamp, all right? So I'm going to have a look at the drawing that we've been given to make this part. So in our working drawings, if I can zoom in over here, we've got some details that we need to follow to manufacture this part. Now we've only been given, oh no we haven't, we've been given two views. Here's an end elevation and we've got a front elevation by here. All dimensions are in millimeters and you can see the dimensions that we've got, running dimensions here. Okay, and we've got some other sizes that we've got to bear in mind. Well, the other thing we've got to think about is the given tolerance with this piece. Stated tolerance for this is 0.5 millimeter, plus or minus 0.5 millimeter, all right? So, sometimes they make things a little bit difficult on drawings. For example, to work out the overall length of this piece of aluminium, you have to add all these dimensions. So you've got 10, 10, 135, 80, 30 and 10. If you add those up, it's 275 millimeters long. And the height of the material there is 12.7 millimeters. You'll get that from the end elevation. The thickness of the material is 3 millimeters. So you will need to obtain stock that looks like that, right? So that piece there is aluminium, brushed aluminium, and it's got a square edge to it, so that's exactly what they specify using. You need to make two of these, by the way, all right? Now let's have a look at some that have gone a little bit wrong, okay? So I have some that have been made too short. That one is too short by 5 millimeters, so that's a scrapper. This one here, for example, oh, okay, there's another problem with this one. The end piece here has to have a clearance hole for M4 drilled in it, and that slot has gone down too deep, so there's no space for the hole to go. I've got one where the balance hole has been drilled too far over, so that will be out. So you have to be careful, you know, measuring and drawing this object is not as straightforward as it may first appear. You might want to, on this, to make your job a bit easier, use engineer's blue to make the surface more suitable for your marking standing out if you're going to scribe it. If you haven't got engineer's blue, you can go for a nice thick Sharpie and you can colour in the area where you're going to be marking out ready to work on. And that'll just come off with some abrasive paper once you're ready to get rid of those lines. Okay, so let's get started and think what we need to do. We need to gather some tools together first of all for marking out. So one of the things you do with your planning would be gathering your toolkit. So you've interpreted the information from the drawing and you've got your stock. That's your first two stages, right? And you've checked what the tolerance is and stuff like that. So let's have a look at the sort of things we might want to use to make this item. So we're going to start off marking out. So which of these tools would you use for marking out? Well, come on, I'll think about it. Do you want to pause it and come back? Which tools are you going to use for marking out? Right, well, obviously, if we're going to make lines using the scriber, which is handy, well, handy, it's essential. We've got an engineer's square for our perpendicular lines. We've got our steel rule for marking out, resolution of 0.5 millimeter, so, you know, within tolerance, 0.5 millimeter, but we might want to get more accurate, so we're going to up the level with that a little bit. Do we need a centre punch? Yeah, well, we're going to be marking where holes are going to go, so we will need a centre punch, and along with that goes an engineer's hammer. Okay, what else? Do we need some spring dividers? Not spring dividers for the marking out job here, but these ones that we call odd leg calipers might be useful, okay? So quite a lot of the kit there that I need for marking out. You can basically just leave the files and spring calipers in. Now, I did say we could up the level of accuracy by thinking about marking out using some slightly different kit. So let's have a look at that. What I've got here is a surface plate. Surface plate is really useful for marking out with metal. Look, with a surface plate, you've got a ground surface that you can guarantee is entirely flat, even though this one has been hit somehow, which is not good. It's entirely flat and you can trust it as a surface to mark from. So what we call that is your datum edge. The datum edge is your trusted edge that you're going to mark from. So that's your horizontal datum. Now, tools that you can use on the surface plate. This is your vernier height gauge. So we call it a vernier height gauge because the scale that you can use for measuring is this vernier scale on the side here. Now it's hard to see this, you have to kind of get closer and actually use it, but you've got two sets of numbers either side of the long ruler that goes up the height gauge, and the one side of it is your vernier scale. Now what your vernier scale you're looking for is lines that line up with the numbers on your ruler that moves, and the one that lines up exactly gives your tenths of millimeters. So first thing you have to do when you're using the height gauge is to drop your height gauge down onto the surface of the material, onto your datum, and check that you haven't got a zero error. So you're going to look at the naught on your ruler and look at the naught on your vernier scale and check they're exactly in line. If they're not exactly in line, you're not marking from 0.00. So you'd have to use the little screw at the top of the height gauge to raise the ruler itself and make sure that the 0 and the 0 line up. So once you've done that, you could use this for marking out parts of your shape. So what I'm going to do, I'm going to set this up to half of 12.7. So I'm going to bring this down, 6.35 I'm after, aren't I? Right, 6.35. 6.35. Okay, there I am. Right, so what I've done now is I've set up the height of my height gauge, my vernier height gauge, to 6.35, now meaning that there's a gap in between the material, so if I can get down any lower than that, the material on the edge for marking out the middle of my material. Now, I can't see that very well, but if I did that using the height gauge, that now has given me a lovely scribed line, 6.35 millimeters up. If you compare that, so good level of accuracy, with the other way that you'd have to do it if you didn't have the vernier height gauge in the surface plate, is by using your odd leg calipers. So for your odd leg calipers, you're going to hook that over the edge of the rule and then dial in, using the screw thread on the end, your distance so that you go to 6. Well, I can go to 6.5. The resolution of this ruler may be half a millimetre if I'm very accurate, which is within tolerance, half a millimetre, just about. So 6.5 there, and then I can use that. Look, you don't need to use a surface plate, but I will do because it's more convenient. You can use that to mark your centre line on your material. So there you go, you've got a centre line that's been marked out with the odd leg calipers, and you've got a centre line that's been marked out with a vernier height gauge. You take your pick which one you want to use, but if it was me, I'd certainly take the time to set up the vernier height gauge. All right, okay, so let's have a look at what else we've got to do. We need to start off from our datum. We've got a horizontal datum, but I'm going to make myself a vertical datum as well, right? Now, my piece is slightly over length at the moment. If I measure it to prove that fact, the length of my piece that I've got here now is 280 millimeters. So I am over length by 5 millimeters. What that means is I can take this edge here and I can scribe, using my engineer's square leg, I can scribe a line that goes down. Now I know that that scribed line is perpendicular to the long edge, the horizontal datum that I've got. So I'm going to measure everything from that trusted line, and we're going to file back to get to that line afterwards. So that's where my edge, my right hand side of the job starts from. Okay, back to the drawing. Got my drawing by here, look, if I zoom down on it. First thing I need to do is to start marking out the distances for these centres. Now, the way it's been marked out here on the drawing is not the best way to mark it out in real life. I'll try and explain why. Okay, so that's my line I just scribed on the material. I need to measure 10 millimeters, there's my 10, to the first hole. If I use a centre punch and centre punch that hole, I then need to measure 30 millimeters to the next hole, and then 80 millimeters to the next hole. Now, say for example, on my first one, I was half a millimeter out. By the time I got to my second one, I was half a millimeter out. I am already now accumulating an error of 1 millimeter. I'm out of tolerance. So it's very important that we measure from the datum edge. So in other words, your first hole, you're going to measure 10. Your second hole, you're going to measure 40. 30 plus 10. So you're always measuring from that back edge. 30 plus 10 is 40, plus 80 is 120. So for my third hole, I would measure 120 from the datum edge to find this point. Hope that makes sense. Doing it that way avoids what we call the accumulated or added error. Right? It's a very important term in terms of engineering, accumulated error. I think we talked about that when we talked about bike chains and wear on individual links. Each link might wear 1/10 of a millimetre. If you've got 10 links, that's going to be 1 millimetre wear, so a lot. Okay, so hopefully that makes sense. So what you're going to do now is you're going to do that in real life. So there, go back to your job. Look, I'm on the height gauge at the moment. Oh, sorry, I'm on the surface plate at the moment. Have I got my long line drawn? No, I'll bring that line straight across like that. So it now runs along the whole length. And I'm going to measure from my datum. There I am, look, right on that point. And I'm going to measure 10 millimetres. Keep on the datum and measure 40 millimetres. So that's the points for my first 2 holes that I've got to make. Now, you could go for the centre punch on there. Put that on the heel of the vise. Where's my vise? See if I can get to this one a minute. Oh, it's too close, sorry. If I can zoom over and look at that vise a moment. Put that on the heel of the vise. Get your centre punch. Line it up accurately. And make a centre punch mark on that point. I hold it there for a minute so it focuses. So that's one good way of doing it. Your other way of doing it is to use the optical centre punch. So the optical centre punch is going to increase your level of accuracy dramatically when you come to mark out the centres of holes. So the optical centre punch is in several parts. You've got the holder on the base, which has got a nice non-slip surface on it. And then you've got a series of sighting pieces that you have that you can look through. So I don't know if you can see that. When you look to the end of it, you've got a crosshair. So you drop that piece into one of the holes on your optical punch. And then you're going to be doing something along the lines of, if I can hold that in place, sighting through there, look, until you can put the crosshairs exactly where you need to centre punch. Hold that steady, don't let it move. In the centre punch, optical centre punch packet, you've got a series of centre punches. Don't let it move, whatever you do. Drop that in and give it a tap with a hammer on the heel of the vise. So that's a better way of marking out the holes. So you're going to mark 1, 2, 3. So that's 10, 40, 120, working off your datum. Don't worry so much about this end at the moment. I'll do that on another video in a second. So these are the stages you've got to plan out. Remember the names of the tools and be technical and be specific and say why you're choosing them. And also, you know, so in other words, you're choosing them to get better level of accuracy, things like that. All right, does that make sense? Hopefully it does. Get all that information down in your planning sheets.